Okay, chapter 3. I know is we're back. Chapter 3. Chapter 3 for module A is only going to have two questions from the homework. These are problems that we actually did for the homework itself. And the reason why it's only two questions because especially with the aliquot question over here, these are more in depth. And so I want to make sure that we are conceptually understanding why we're picking each number instead of just memorizing this way to do this, because there are different questions that can be asked. And some of us probably saw this in the exam, for example. And you don't want to go in a way, you don't want to go by these questions where you're just like, okay, I say do this, this, and this, and I get an answer. Because, like I said, when there's probably a variety of questions that can be asked, you might just go by what you have memorized and then just totally forget, totally like, go above like what's being asked right here. So I'm going to show you like what can be possibly asked, right? And so let's go ahead with number 2. A torsion prescription balance has a sensitivity requirement of 4 milligrams. What does that even mean, right? So prescription balance, what balance is used to measure amounts of drugs for later measurements and whatever we are trying to create, pills or whatnot, right? These balances have a requirement of 4 milligrams sensitivity. What does that mean? That is the cutoff before it goes severely off imbalance, basically. And there's going to be some error within range of like 4 if you go above or a little lower, but be way below 4 milligrams. 4 milligrams is a cutoff. Anything below that is going to be severe inaccuracy. So the question goes, explain how you would weigh 5 milligrams of hydromorphone hydrochloride with an error not greater than 5%. So within a balance, even if you are a little bit above 4 milligrams, there might be some inaccuracy with, and we'll see that later with percentage error. What does that mean, right? So we want to find a way where we can get enough of a drug where there is less than 5% or less than or equal to 5% error. And so how do we do that, right? We find the minimum quantity that we can weigh that meets these requirements of precision, basically, and then dilute that into a larger quantity, and then we extract that minimum quantity needed to satisfy what we want, which what we want is 5 milligrams of hydromorphone hydrochloride. So it's going to make a lot more sense as we write it out, okay? So starting off, we need to find the minimum quantity of a substance where we can weigh, that we can weigh in which it will meet the requirements of 4 milligrams sensitivity requirement and error less than 5%. How do we go about that? We divide 4 milligrams by 0.05. Those are our requirements for precision. That's what we're dividing here. 5% equals 0.05. If you want to divide it by 5%, you can multiply by 100. Don't overcomplicate it for yourself, right? We know 5% is 0.05. I mean, do whatever you want that makes it, easier for you, but you also don't want to add too many steps at the same time. 4 divided by 0.05, see what that is. 4 divided by 0.05, 80. How about that? It's a good number. So that's the minimum amount of a substance, basically, or in this case, the drug that we can pull out that will meet the requirement of sensitivity and also have an error less than 5%, not greater than 5%, equal to 5%, whatnot, right? Okay, so that's also known as your least weighable quantity, just by definitions. That's something they can ask you. Hint, hint. Okay, so now we have our least weighable quantity that we can extract from our aliquot, or from our greater amounts that we are making to be able to extract 5 milligrams of hydromorphone. Now we need to know how much drug we're putting in for this solution and how much, let's just say how much diluent we need as well, right? That's one question that can be asked, for example. So technically, so how we go about this, right? You can, to make these aliquots, you're gonna have proportions. You can multiply it by any number. You can multiply by 5, in this case 5, 10, anything. So, but the exam, for example, asks for the minimum quantity of that, of proportion wise and whatnot. Why is that conceptually, right? Think, imagine yourself owning your own pharmacy. You don't want to waste any, exorbitant amount of drug to make this thing because that's money out of your own pocket to take a piece of and hand out to a patient later on. So best way about it is to just calculate the least amount possible. To do that, we get our least weighable quantity that we extract later on once the aliquot is made. That's 80 divided by how much we want, 5. 80 divided by 5 is 16. Okay, that's great. It's a whole number. If it's a decimal, let's say 16.5 or 4, whatever, 16.4, we go up to the next whole number. Okay, so thankfully this is a whole number. And so we know now that for our aliquot size, we need 80 milligrams of drug. Okay? And then, so we know how much drug we need for our aliquot based off of this proportion. We're multiplying by that proportion, right? We also need to know how much diluent that we need. So how do we go and solve for that, right? This is, remember conceptually, right? This is the amount that we are extracting from the total solution to get an amount of 5 milligrams of hydromorphone hydrochloride, right? Total solution. So if we're multiplying this proportion for the drug, we also need to get the total amount of solution. So we need to multiply 80 times 16. 80 times 16, 8, 6, 48, 8 times 1, 1,280. Let's check that out. 80 times 16. About that. Cool. So I'm going to write this out, right? Minimum, the drug that we're looking for, the amount of drug that we're looking for, times our proportion. So that's how much drug we're using. This is the amount that we are extracting that's going to contain both the drug and the solution, the diluent, basically, right? And to get our desired amount of drug from our grand solution, right? We had to multiply that by a proportion to get our total amount of both drug and diluent. So that's 1280 milligrams. That's the total. To get how much diluent we used, subtract this by that. Easy. So 1280 minus 80 equals 1200 diluent. That could be lactose, dextrose. It says use lactose as the diluent. So that's 1200 milligrams of lactose. So what questions can be asked in which you need to get these answers, right? So explain how you would get 5 milligrams of hydromorphone hydrochloride. You did this whole thing right here. They can ask how much diluent was needed. That's that extra step right here. Because technically you didn't even have to do this at all. You could have just stopped right here. But if they asked for how much diluent was used in this aliquot exercise, right, or whatnot, that's the 1200 milligrams diluent. they can ask you how much drug or how much was extracted to get the amount of drug desired. That's this number. And you want to make sure that just because these look the same, you're not looking at this number. You have to make sure it's this number. Because if you're multiplying it by a different proportion, these numbers are not going to look the same. So you want to make sure that you're pulling this LWQ to extract that amount of 5 milligrams of hydromorphone hydrochloride. So repeat one last time. You can't get 5 milligrams directly from on this scale. So what you do is you make this solution with both drug and a diluent, and you're trying to extract the least amount possible, and you're trying to use the least amount possible to make the solution and to extract the same amount, right? So how do we do that? We calculate how much we need to, the minimum amount that we can extract to get the amount desired, 5 milligrams, without exceeding our precision requirements, 5% error, and 4 milligrams of sensitivity. We got a proportion to the minimum amount that we can, the proportion used to make the minimum amount of our aliquot, 16, multiply it by our desired drug, that proportionally to get 80 milligrams, which just so happens to equal LWQ. Remember that. And then this is how much is being extracted from the total solution. So we also need to multiply that by the proportion to find out how much of the total solution is with both the drug and the diluent. So that's the total amount. And then if they were asking to find what the diluent is, do subtraction. So I think it sounds simple at first, but you need to make sure you know you're reading what the question asked for. Because if they ask for how much was extracted, then that's a different story. It's not any of this. You need to make sure it's this. Cool. Okay. Number 5. In preparing a certain ointment, a pharmacist used 28.35 grams of zinc oxide instead of the 31.1 grams called for. Calculate the percentage of error, so just rewording, on the basis of the desired quantity, right? Okay, so let's write our equation for that, right? So to get percent error, you need to subtract what was actually calculated. So that subtracted by what was desired and divided by what was desired. And then multiply it by 100 because percentage, right? So let's go ahead and do that. So pharmacists used 28.35 grams of zinc oxide. So that was what was actually measured out, right? What he wanted was 31.1 grams. So you can do, either way is fine, right? 31.1 minus 28.35 divided by what was desired, 31.1, and then multiply it by 100. Handy dandy calc. Let's clear that out. 31.1 minus 28.35 divided by 31.1 times 100. So that's what we get. We can go for, it depends, right? So the question is asking in terms of like sig figs, for example, right? We want to go between what is given and what is actually weighed. You want to go, in this case, with 3 sig figs. So 8.84%. That one's a lot more simpler than that, right? But aliquot is the one that you really want to just understand, why are we getting this number? Therefore, when the question arises of what you need to be picking out, you know where to get it from. All right, that's it for chapter 3. Moving on to the next chapter. This is going to be very quick, just 1 or 2 questions per chapter, and then we'll move on to the other modules as well.